Hi, in this video we are going to see an instance of our bad design. So this is a table given branch name, branch city, assets, customer name, loan number and amount. And for this relation we have given different attributes like branch name, branch city, assets and etc. So why we are saying that this is an instance of a bad design? If you take this example, the relation lending with the schema is an example of a bad design. So the relation lending with schema. Schema in the sense it represents the structure of the database, that is database description. Lending schema is equal to branch name, branch city, assets, customer name, loan number and amount. What is this one? Lending schema. So lending schema, it defines the relation name for this relation. So this is the relation name. For this relation, they have given different attributes like branch name, branch city, assets, customer name, loan number and amount. So looking at the downtown and Perry Ridge, when a new loan is added, the branch, city and assets must be repeated. If you take this downtown and Perry Ridge, so downtown and Perry Ridge, if you take this, when a new loan, if you are going to add a new loan to this, the branch, city and assets must be repeated. Additional problems come from having two people take out one loan. If you take that L23. So here for the Redwood, the loan number is L23, and for downtown, the loan number is L23. So this is a good example of our bad design. So what we are going to do? So we are going for decomposition. The obvious solution is that we should decompose this relation. So as an alternative design, we are having some decomposition rule. That is, if A implies B, then C and B C, then A implies B and A implies C. This gives us a schema. Branch customer schema is equal to branch name, branch city, assets, customer name, and one more schema, that is customer loan schema, is equal to customer name, loan number and amount. This is how we can decompose and then we give a proper solution for this. So here this is a decomposition. So downtown, Brooklyn, assets, customer name. So here branch name, branch city, assets and customer name. And the next thing we are having one more thing called customer name and then loan number and amount. So if we have like this, then if we have decomposed this kind of relation, then we can easily solve this problem. So looking at the downtown and Berry Ridge, when a new loan is added, the branch, city and assets must be repeated. So still problem exists. Problems come from having two people take out one loan. L23 problems still exist. More complexity is involved when Jones took out a loan at the second branch. Problems still exist. We are no longer able to represent in the database information about which customers are borrows from which branch. This is called a lossy decomposition or lossy joint decomposition. A decomposition that is not a lossy decomposition is a lossless joint decomposition. The proper way to decomposition this example so that we can have a lossless joint is to use three relations. One is branch schema and another one is loan schema and another one is borrower schema, and the relevant attributes are given here. This is how we can solve. Suppose if we have made a small problem in our design, so when they call our design as a bad design, so if we are going for decomposition, then we can easily solve this issue. Thank you.